Hello everybody and welcome to section 5. This is going to cover something on the interior of the Earth. Question here, how do we know what's inside the Earth? For Unit 1, you were given this model of the Earth. The crust, mantle, liquid outer core, solid inner core. How are they so sure that that's what's down there? What makes them so confident? How does anybody know if we've never been there? Well, Earth's interior has a number of different ways that it can be imaged. Even though we can't go there ourselves, we use a technique whereby we can get information about something at a distance. It's called remote sensing. The same way that your eyes can sense what's going on the wall in front of you without necessarily having to touch the wall, we can use waves inside of the Earth to get a sense for the structure and get a sense for what's going on down there without ever having to physically come into contact with any of it. And we do this for the most part with seismic waves. There's an earthquake somewhere, we listen to those waves all over the world at different stations, and we piece together using differences from those stations to get an idea of what the interior structure of the Earth most likely looks like. So here we have the epicenter of a massive earthquake, something that is so big that it can be felt all over the world. Notice that we have our P waves, our primary waves, in black, and our slow waves, secondary waves, in red. So here is the original source of all these waves, and we have all these listening stations all over the world which are talking to one another. So P and S waves, the S waves, come to the outer core, and what we think happens, well, maybe this is a better example, what we think happens is that they are deflected. They bounce off and come back to the surface. So if somebody were right here and they have their seismic ears listening to the ground, they would not hear those S waves. They would only get the P waves because there's no path for the S wave to get there. It comes here out of the epicenter. It hits the core, and it gets deflected off somewhere in here. And so, on the opposite side of the world from the earthquake, we would have this massive S-wave shadow zone. And you would think, well, why would there be this, the P-wave shadow zone, considering that P waves go through solid and liquid? Well, whenever a wave like this passes into a medium which is not like what it's traveling through, right? So here, going from something which is mostly solid to something which is entirely liquid, it deflects. It starts to travel at a different angle through that. So if a P wave comes right here, it travels, it just barely misses the core, and then it's going to come out right here, as opposed to its neighbor. P wave comes here, it hits the core, and then it is deflected downward. So then there would be this whole region of the world which does not hear the P and S waves from this earthquake. You have another one on the opposite side here. And using the fact that P waves travel through solid and liquid, but S waves do not travel through liquid, there's a pretty sure way that we can image the solid and liquid structure of the core here and have a pretty good idea of what's going on in the interior of the Earth using earthquakes, which happen all around the world, and a global listening station, little seismic ears picking it up. So, what are some of the other ways that we know what is going on in the interior of the Earth? Well, sometimes we have magmatic activity. We would have something like a volcano. We would have something which is an old magma chamber which has dried up and crystallized. We can also have cases where magma comes up to the surface, and when it is expelled through a volcano, it carries with it these little chunks of what was down there very, very deep in the surface. We actually call these xenoliths, things that it's brought up from the mantle through the conduit pipe and then burst out onto the surface. And of course, the way that we get the best information is near the surface we can't drill. Drilling is very expensive, and so usually this is only done whenever we have a very good idea of what we're looking for, what we expect, and some idea of having exhausted all the other techniques. So, what is the deepest into the Earth that mankind has ever gone? This would be the Kola Super Deep Borehole. This is in Russia. This was actually during the Cold War. I think this was actually drilled starting in the 70s all the way up through the mid 90s, part of the competition with the US that was going on in the scientific fields at the time. Uh, Russia won this one. They managed to get 12.3 kilometers deep. This is further into the ground than Mount Everest is high and further down than the Mariana Trench, which is the lowest point on the surface of the ocean. Uh, Despite this being pretty far down there, 12.3 kilometers deep, this is nowhere near the crust mantle boundary, which is actually about 3 times further than this on the continents. Nowhere near enough for us to get to the really, really interesting stuff. Next section is going to be on measuring earthquakes.